Next topic is Hadoop Hive. So let's talk about the topics. So here we are going to talk about what is and why use Hive. And we'll talk about Hive architecture. And we are going to see Hive QL language. And we are going to see physical layout of Hive QL structure on the HDFS. And we are going to see how we can load data into Hive tables and the concept of partitions and joining and buckets. So what is and why Hive? Hive provides data warehousing solution built on the top of Hadoop. So it's built on the top of Hadoop, so it takes advantage of distributed, reliable, scalable solution. Okay. Now, Hive comes with SQL-like language called Hive QL. So this is the biggest advantage of using Hive as a query language. So if you have in-house developer the resource who are familiar with the SQL, now you can use Hive QL, which is very similar, in fact, almost one-to-one match with the SQL-like language. You can actually use Hive to do data analysis. So you can do querying, analyzing, summarizing large amounts of data. So Hive is designed for people who are already familiar with the SQL. And it allows you to project structure to any data format. So unlike SQL, it can handle non-structured data. It's open source project on Apache, and it started at Facebook before it became Apache top-level project. Hive is not designed for real-time queries. Okay? So Hive, like a pig or a MapReduce, is still a batch operation. So Hadoop jobs incur substantial overheads in job submission and scheduling. So this is still not for real-time queries. Okay. Later on, we're going to actually learn the solutions that provides a real-time query. That is basically HBase. Okay. But Hive is still for batch operation. So as a result, latency for Hive queries generally very high, meaning it could take minutes with reasonable size of data set. Even very small, I mean, it could actually take minutes rather than seconds. Okay, so this is not for a real-time query. Okay, so Hive is not designed for low latency responses, meaning real-time queries, but it is designed for scalability and ease of use. Okay, so Hive is not for online transaction processing, which requires real-time and frequent write operations. It is designed for OLAP, online transaction analysis, in batch mode. Okay, which requires mostly read operations. So Hive does not support update or delete or insert a single row. Okay. Example Hive applications, so log processing, text mining, document indexing, and customer-facing business intelligence and predictive modeling, hypothesis testing. So these are the operations that you want to perform in batch mode. So these are analysis, basically operation, OLAP, not OLTP. So let's compare Hive against RDBMS. Okay, so similarities between the two. Both provides SQL-like language. So Hive provides Hive QL, and RDBMS, of course, provides SQL. Okay, so Hive QL is like SQL language. It does provide a similar data model. So concept of database, concept of table, concept of view, they're all present in both Hive and RDBMS. Okay, now differences. So again, Hive is designed for OLAP in batch mode, while RDBMS, relational database, is designed for OLTP in real-time and low latency operations. Okay, Hive is schema on read, while RDBMS is the schema on write. Meaning in RDBMS, relational database. When the data is written to the table, the data has to meet the schema that is already specified. It has to meet in a very strict terms when the data is written to the table. On the other hand, Hive, any data format could be written to the table, to the data set, but when it reads the data, it could impose some schema. Okay. Okay, so let's compare Hive against Pig. So similarities. Both of them are batch oriented. Okay, and both Pig and Hive statements are translated into map-reduce jobs underneath. Okay, and Hive is targeted for non-Java developers, and Pig is also targeted for non-Java developers. Hive, in the case of Hive, is targeted for SQL developers. Right? So in both, in both technologies, non-Java programmers can actually use the technologies to do data analysis. Okay. Again, in the case of Hive, mostly it is for SQL developers. Okay. Differences. The HiveQL, like SQL, is a declarative language with a single result set, just like SQL. One single statement will result in result set. Okay. In Pig, it's a procedural data flow language, as we talked about, right? So each statement will receive input, it will generate an output. Okay. Okay, Hive architecture. So Hive internals. So Hive translates Hive QL statements into a set of map-reduce jobs, which are then executed on a Hadoop cluster. Okay. Abstracted notions of traditional RDBMS are provided over Hadoop datasets through metadata store. So the concept of database, concept of tables, concept of schemas, concept of indexing and view, these are provided in Hive. Okay, so you can think of database as a namespace containing set of tables. Hive-specific data models are also supported, and we are going to learn the concept of partitions and buckets. So this picture shows Hive architecture. So the way that you can use Hive is you can use it at the command line, or you can use a web interface, or you can actually access Hive tables through what is called the Thrift server. So in this case, any JDBC and ODBC client application can access Hive. Okay. As I said before, the table information is actually maintained in a form of a metadata. So this metadata store is maintained internally using embedded Derby Java DB database. However, if you want more production quality database for maintaining this metadata, you can use other database technologies such as MySQL or Postgres and things like that. So this metadata store maintains information about table definitions and how those tables are mapped into HDFS files and things like that. Okay. Okay, so let's move on to HiveQL language. So HiveQL provides these three different types of operations: DDL operations and DML operations and SQL operations. Okay. The way you can execute HiveQL is that just like a pig, you can just type Hive to get a Hive shell, and then you can specify Hive command, or you can run Hive script files. So in that case, you say Hive-F and the name of the script file. Okay, so you're going to try both. Now, examples of DDL operations include create table, show tables, describe table, and drop table. Okay, so as you can see, this is very similar to SQL, right? So let's take a look at the create table. So here you say create table if not exists. So this one looks exactly like SQL, right? So I'm creating students table. If it doesn't exist, if it already exists, then I'm not gonna create it. And it contains name field and hobby field, year field, and month field. Again, this is exactly like SQL. Now there are a couple of things that are different here. Row format delimited. Okay. So the delimiter definition has to be specified here. So row format delimited, so each row will be delimited. So row format delimited. Here you can specify fields delimiter and the lines delimiter information. So in this case, I say fields terminated by comma, lines terminated by the new line. Okay, so these three lines might be different from SQL. These three lines are Hive specific because it's trying to create table based on the some delimiter information. Okay, show tables. Yeah, this is exactly like in SQL. You can see the list of the tables. Describe students. Okay, so same thing in SQL. You can find out the schema of the students table. Drop table students. Again, exactly like in SQL. You can drop a table. Okay. DML operations. So you can load flat files into Hive. Okay, so here you say load data in path. Okay, and the name of the file. Okay, so in this case, it's actually referencing to HDFS file and override into table students. So here, basically, if the students table has data, it will override it. Okay, meaning it will delete the existing existing data and will load fresh. Okay. No verification of incoming data. If the loaded data is not compliant with the schema specified for the table, it will be set to null. Okay. So in the case of the pig, it was set to empty, and here it is set to null. Okay. Okay, once data is loaded into tables, then you can perform query operation using select statement. Again, just like SQL. So you can say retrieve all students. So select stuff from students underscore external table. So students underscore external is just happen to be the name of the table. Okay, so count number of students. You are using count function. And the next example is to retrieve students whose hobby is golf. So you are going to use a where clause, just like SQL. Okay. The last one is retrieve students who was born in 1990. So where equal year equal 1990, display up to 3 rows, limit 3. Okay. So you can see, HiveQL is very, very close to SQL. HiveQL also has a built-in functions, just like a pig. Okay, so you can actually see within the Hive shell, you can say show functions, and you can see all these functions, okay, which you can use in your Hive statement. Now, let's talk about the physical layout. Hive warehouse directory in HDFS. So the metastore directory is actually specified. This is the the default. In the configuration file, you will see hive.metastore.warehouse.dev file. That will actually point where your Hive metastore is. Hive is maintaining its metastore information. As a default, it's using /user/hive/warehouse. That's the default. Okay, so any tables in Hive, any Hive tables will be created under this directory, user Hive warehouse. Okay, so if you want to have a different directory, then you can change that hive.metastore warehouse.dir the configuration attribute. Now, Hive table is represented as a directory on the Hive warehouse directory we mentioned above. Okay. So if you happen to have a students directory, that represents students Hive table. And if you have a book directory, so like a users Hive warehouse/book directory, that represents a book Hive table. And under that table, under that directory, you have in fact the data files in the form of a flat file that contains the actual data. Okay. So when we say Hive table, we are basically talking about a directory under this warehouse directory of HDFS, which is as a default user Hive warehouse. And we're going to actually take a look at all this in our hands-on lab. Okay, so this picture shows, so the user Hive warehouse, I have in fact created 5 tables. So I have a book table, Hive test table, sample 07, sample 08, and zip code underscore income these are all directories, and each of these directories represent Hive table. Okay, so let's do exercise 1. Okay, so we are going to go Hive, samples Hive, directory of this hands-on lab. And you can see I have provided bunch of script, okay, and I named them as Hive as an extension, okay. All right, so you can take a look at a few scripts. So I'm gonna, let's take a look at the book HDFS internal create Hive script. Okay. So it creates a table if not exist. So I'm creating a book table, and it has a single column called word, and row format delimited. And so row format delimited is actually for providing fields delimiter as well as line delimiter. Okay, so fields delimiter is going to be just a space, and we want to then we want to see all the tables. So we should actually see a book here, and then we want to display the schema of the book table. And if you want to see more detailed information about the schema, then you can say describe extended book. Okay, so we're going to try these things in the shell one by one later on. Okay, all right, we can take a look at HDFS internal load Hive. Okay, so that is this guy. So in this case, load data in path, we are just loading this big so now we create a table here, right? So we create a table, and then we are loading data. Okay, and then we are going to perform query operation. So the scripts are actually designed, kind of separated out for your better understanding. So I have a script that does create a table and load. I have a script that loads the data. So that is this guy. So book HDFS internal load, and then I have a book HDFS internal query operation. So in this case, we are performing various select operations. Okay, so again, this is exactly the same that I showed you in the So in this case, I want to get all the books, and I want to just to see 20 of those. And here retrieve the first 20 non-blank words. So this one, should be non-blank. And query the count of words in the book table. So I use count. And here, query the count of words in the book table whose first first lower letter start with T. This one is list the words whose starting character is T and the number of occurrences is more than 5. So we are having count 5 and sort by. Okay, so having group by and having. So this is exactly like what you see in SQL, right? Okay. Okay, so we are going to start the Hive shell. Okay, so you say just Hive like this. And you can actually display Hive settings by set -v, and every command has to end with the semicolon, just like the SQL client command, MySQL client command. Okay, and you can also use some Unix command by using bang. So if I want to list all the files on the current directory, then I can say /ls and like this. Okay, it's actually displaying the files in local file system. Okay, not the HDFS. Okay. Okay, so now we are going to perform. You can also perform cat operation. Okay, so you can say cat and Hive and like this. So it display the contents of this file. And you can also see the built-in functions. You can say show functions, and these are all the functions that are available that you can use. Okay, there are a lot. And you can actually see, if you want to see how you can use ear function, you can just say display function extend it here, and it actually give you even some examples, okay, like this, okay. All right, now 1.3, you are going to run Hive commands within the Hive shell. So here you are creating a book table, and then you are specifying delimiter definitions with fields and lines, okay. And then when you say show tables, you should actually see book here, okay. So since I have already created, I can just say show tables. Oops. What is going on? Runtime unable to instantiate Apache Hadoop. Oh, okay. So in my case, I have Hive is actually deactivated. That's why. Okay. So I have to actually activate it. Okay, so Hive, it is actually stopped. That's why it didn't work. So I'm going to start the Hive server. Okay, so it's getting started. Okay, so it started, and if I say show tables, now it should actually display all the tables that I've created. Employees, Hive test table. Looks like a book has not, yeah, I have not created it yet. Okay, so once I created it, then it should actually show book here. Okay, and you can specify, you can use describe to see the schema. So in this case, the book has just word column. Okay, and you can also display more detailed information about that book schema, so a lot more information. And then you can actually see this book directory has been created. So as we talked about, every Hive table should be created on the user's Hive warehouse. Okay, so if I go to, in my case, so let's say I have a people table, right? So in my case, I should actually see the people on the HDFS name node, browse file system, and it should be user, Hive, and warehouse. So these are the directories. Each of these represents Hive tables. So if I go to employees directory, these files are representing the actual employee data. Okay. Okay, so that is making sure those tables are created in the form of directories on the Hive meta store directory. So there's no files on the book directory because we have not loaded any data in the book table yet. So now we're going to load it. So here, we are going to copy. Yeah, we are going to copy Hadoop FS Tom Sawyer big.text my data. We probably already have done that in our previous exercises, okay? And then we are going to load. So we are going to load this Tom Sawyer big text file into book, okay? By the way, so if you experience the following problems, it's because the big text file is not present in HTFS, which means that you have not, copied the file into HTFS yet, okay? And then you can actually verify in the book directory, you should see the file here, okay? Then you can perform query operations. So we want to actually see, everything from a book, okay? So here we are going to see, the 20 rows basically, okay? So in this case, every word is gonna be captured in a form of a row because that's the way we created a table, right? Okay. So now we want to actually see 20 non-blank words. So in this case, we are using where clause. Okay. So in this case, we should actually see this. Okay. Yeah, I don't know why this is probably not correct, but probably this one I have captured incorrectly. Okay. And in this case, I want to see how many words there is in a book. So it's in select count, and then it should be 9206. In this case, we want to see count the words in the book whose lowered first letter start with a T. Okay, so in this case, what we should see is 1097 words start with the either capital T or small t. Okay, this one is query the words whose lowered starting character is T and the number of occurrences is more than 5. So we're using having as well, group by and having. Okay, so this is what you should see. And you can drop the table. Okay, and then if you go to that directory, user Hive warehouse, and refresh the page, you should not see book anymore. Okay. Okay, so I'm going to give you guys I'll give you guys 10 minutes to try exercise 1. Now let's learn a bit more in terms of how we can load data into Hive tables. Okay, so we have already seen examples of loading data into Hive tables, and there are a few variations in loading data into Hive tables. So there are multiple schemes you can use to load data into Hive tables. The first scheme is again using load data command, Hive load data command. Again, this is most common way of loading data, and this is our focus. So this is to load data from flat files, and so data files can be loaded from local or HDFS. Then HDFS is the default. Okay. If you want to load from local file system, then you have to specify it with the local, and we are going to see examples of that in a few minutes. And data files can be loaded internal or external. So the internal, which is a default, and external, which is not a default. Again, we're going to talk about these two schemes in detail in the following slide. Okay. Okay, so or you can manually copying data files into user Hive warehouse and table directory. So if you create a table directory and then if you just copy files underneath it, then Hive will automatically recognize those tables, those directories as Hive table. Okay, so you can create a table under this metastore directory, and then it will be recognized as a table by Hive. And you can copy some data on that files. Okay. You can also use insert command. By the way, this insert is not like SQL insert where you can insert a record into a table. That's not like that. So this insert in Hive is load data from another Hive table into So this is basically getting data from existing Hive table to another table. So this is where you are going to use the insert command. Okay, so don't be confused by the name of this command. It's not for inserting into a table. You can also use Scoop. We're going to talk about Scoop tomorrow. Basically, Scoop is a technology that you can use to move RDBMS data, relational database table, to Hadoop and vice versa. Okay. You can also use a Flume to move large data sets to Hadoop. Again, this is something we are going to talk about tomorrow. Flume is used to, for example, if you have a streaming log file, and you want to capture those streaming log file into Hadoop database, you can actually use it as well. So you can actually move those streaming data into Hadoop the Hive table. Okay, so in this presentation, we are going to mostly focus on the number 1, and later on, we are going to do number 3 as well. Okay. Okay, so loading data from locale versus HDFS. So loading data from HDFS is the default, and if you want to load data from local file system, then you have to specify locale here. Okay, so if I say local, basically this is the directory in the local file system. Okay. And the first time so this is the student data 1990, and then I'm loading student data 1991. So, I'm actually using these two data files to fill up students table. Okay. The first time I'm overriding so that I am, starting from scratch. And second time I don't want to override, because if I do, then I'm actually erasing the data that I just loaded, right? Okay. So in this case, I'm loading student data 1990 text, student data 1991 that text from the local file system. Okay. Loading data from HDFS. So if you don't have this locale here, then it will try to find data from HDFS. So in this case, it will try to load data from my data students directory. Okay. Into students table. So this is the default. Okay, so the only difference between local file system versus the HDFS is that for local file system, you have to specify load. Okay. Okay, the internal versus external. So this is a little bit interesting behavior. So if you are loading internally, data is moved to Hive storage. Okay, so what happens is that if you have a student, so let me actually show you. So this is the case that so let's talk about this HDFS case. This is in fact internal loading, okay? Meaning, this student's data 99 that text file is from HDFS. This file will be actually moved to students directory of Hive Metastore directory. Okay, so that's internal. So what happens is that in that case, when you delete Hive table, so when you drop the Hive table, the data will be deleted as well. Okay. Now, when you do external loadings, so you're gonna load data with the external with the location. That means existing data will be still there. Okay, and the Hive table will just have a pointer. So Hive table, will not have any, let's say, the flat files underneath the directory. Okay, it will just have a pointers. So deleting a Hive table, meaning dropping a Hive table, will not delete the files in HDFS. Okay, so we're gonna actually do this one in the exercises, and you'll understand what I'm talking about. Okay. So this is the first case, is loading data internally. So it doesn't use external and location. So what it means is that this file in HDFS will be physically moved into the Hive Metastore directory. Okay. In this case, when you're using external, okay, by the way, when you do using external, this is actually something you use in create time, not load time. So you don't actually have a load command. Okay. So when you create a table, you are actually indicating the actual data table is external from this Hive table. And then you specify the actual location of the data. Okay? So this is the external case. So you don't have a load statement, but it's done at the create time. So in this case, even if you drop the student's external table, it will not delete this HDFS files. Okay, in this case directory. Okay, but load data internal, because this file will be physically moved to Hive Metastore directory. So when you drop the table, it will delete the directory. So Hive directory. So that means any files underneath will be deleted as well. Okay, so this is a case that you can use insert. So again, insert is used when you want to load data from existing table or tables. Okay, so this is not for SQL insert where you are adding a row. Okay, so in this case, let's say we are creating a table called the people. We create a people table, and we want to we want to load data from students table to people table. So student table is already existent. Okay. So here, insert override table people, select name and hobby from students external. So, in this case, performing query operation and select operation to students external. So the name and hobby will be copied into or loaded into the people table. Okay, so that's when we are using insert. Okay. Okay, so let's take a look at exercise 2. So the first, we are going to load data from a local file system and internally. So when you so we are going to actually take a look at the create command. Okay, so when you see the create command, we create the table, students table, and because we haven't used we actually create the table. Okay, and so we're going to actually perform that so we are going to perform create. So we are actually creating a table. So we create this students table. Okay. And then we're gonna perform loading. So if you take a look at the load script, so we are loading from a local file system. Okay. So we have the sample data, so we are going to load the students from a local file system. Okay. So it's going to be recreated because, so we actually recreated it here. So we say create table if not exist. Oh, okay, if not exist, meaning if the table is already there, then, it's not going to create one, but it's going to load it, okay? And we say override, so it's going to delete the existing data and then it will, load this data fresh, okay? Okay, so now you can actually take a look at the this warehouse. So this is, if you can go to students, let's go to students. So we should have we should see students, right? You can see the time, October 28th, 12:54, which is a Pacific time, is 3:54 in Eastern time. So if I go to students, I see these two files that I just loaded. Okay. All right. Okay, so we verify that. And then we can perform query operations. So, this is the student local internal query Hive. Okay. So, I'm going to just use the, I'm going to just use the Hive shell, Hive, and we are going to perform select from, I'm going to just copy this guy and then run this guy, and it should return students, and it should be sorted by name. Okay, and I can actually perform few other select statement. Okay, and then I can drop the table. Okay, so once I drop the table, so you can actually certainly show tables, and then you can drop table, and then if you say show tables, then the table should be gone. And again, if you refresh the page of user Hive warehouse, you should not see book here anymore. Okay. Okay, so that is actually loading data internally and loading data from local file system and internally. Now the next one is we are going to load data from HDFS. Okay, which is a default. Okay, so again we create the table. So this is pretty much the same logic here. Okay, so the so this is the result you should see, and we want to copy. So we want to copy files into HDFS. So basically sample data, and we want to make sure we have a students directory. So let's actually make sure we have the students directory. I probably have it already. Okay. Oops. Oops. Oh, I should actually say it, the command line, not Hive. Okay. And I probably have it. So yes, it already exists, and I probably copied the files already. So I should probably have these two files. So I'm going to just move ahead, and then so I should have these two files. Okay. on the my data students, and I want to actually load data from this HDFS. Okay, so now if I take a look at the HDFS internal, I don't see any local here, right? So that's the reason it's actually trying to load from my data students and from the HDFS. Okay, so if I do this, it's going to load from HDFS. Okay, and again, so now again, if you take a look at this guy, so this is actually interesting. Yeah, so this is something I want to actually show you. Okay. Now, if you take a look at the when you load data from HDFS, okay, I used to have so let's actually go to namespace. Actually, I should actually show those things first. So let me actually show you user data, user Cloudra, and I was that my data? My data students. Okay. So I used to have these two files, right? But once I actually load it, okay, this is one I want to actually, understand. Once my students, I go to my data, and if I go to students, you don't see these two files anymore because those two files are in fact physically moved to Hive, the table directory. So let's actually go to the Hive. So I'm going to actually go to name node and browse and user Hive and warehouse and students. Okay, so you now see these two files moved from HDFS to this metastore directory. Okay, so now when I actually delete, if I drop students, so let's actually drop this student, and then you are going to see these two files are in fact removed as well. Okay, so I'm going to drop. So I'm going to say Hive. And let's say show tables. So we should see students table here. So we see students, right? Okay, so I'm going to drop it. Drop table student. So now if I say show tables, I should not see students anymore, right? Now, I should not see the students directory on the user Hive warehouse as well. So if I refresh it, it's going to say there is no directory like that. See, students does not exist. Okay, so the if basically I can go to namespace and the user Hive warehouse. I don't see students anymore, meaning those two text files are gone. Okay, so this is in fact the implication when you're using internal loading. Okay, so when you're using HDFS and internal, so the files are physically moved from HDFS to Hive table, and when you delete the Hive table, those data is going to be gone. Okay, so that's basically what we are actually doing here. So observe that which represents student table is also text and yes, so files and then perform query. You can perform query operation and then drop the table. Then the book directory is no longer in the. So we are actually dealing with a book here. Okay, all right. Oh, actually, so this is actually should be. Yeah, I should say students. Okay, so this is my mistake. It's students. Okay. All right, so that is internal HDFS. So now we are going to use external. So when you do external, basically you are going to specify when you create a table, you specify I want to create a table, but the actual data is in HDFS, and I want to just have a pointers. Okay. So again, we have to actually copy this students data again because we don't have those files anymore. So if you go to, for example, the namespace and then go to user Cloudra, my data, and if you go to students, you don't see those two files anymore, right? So that's the reason we have to copy this one again so that we can do this exercise. So let's just copy these files again. So I go to and sample data, And we're going to copy these files again. So now we should see, if I refresh it, I should see these two files, right? Okay. All right. Now we are going to use external location. So if you take a look at this, the students HDFS external create Hive script. So we are going to move again and sample Hive. And if I take a look at this script, it's actually using external, and this is the location of the files. Okay, so when I run this guy, Hive table gets created, but it will just have a pointer while leaving the data in the HDFS. Okay, so it actually creating student external. It's actually creating student external table. Okay, so if I actually go back here, namespace. Okay, and if I go to user, the Hive, we should see student external. Where is the student external? Oh, yeah, we have created students external. Why it doesn't show it? Okay, so let's see what. So I'm gonna just take a look at the tables. Show tables. Oh yeah, so here you go. Students external here. Okay. Students external. So why is not showing? Okay. So because it's external, the pointer is there, okay, but the actual directory is not gonna get created. Okay. So yeah. So that's yeah. So I can actually still see student external here. Okay. But the actual directory is not gonna be created. Okay. So now we can actually perform query operations. So I can actually do the student external table. So here I can say select star from student external table, and it should actually display all the students from the students external table. Okay. Now here again, so I can say show tables. Now in this case, even if I drop the table, the actual data will be still there, okay? Because Hive is just pointing to the data. It doesn't really, they physically have it, okay? So let's actually drop the table. So I'm gonna say drop table student external, okay? And if I say show tables, it should not have students external anymore. Now here, even if you actually go to the my data students, even if I actually refresh it, this data still are present in HDFS, okay? Because these were externally pointed by HDFS table. And even if HDFS table got deleted, this data should be still there, okay? So that is the exercise. And okay, so next one is using insert, okay? So if you take a look at the create student, yeah, so we're creating students table again, okay, externally. So we are going to just we are creating the students table, student external table externally, okay. And then what we want to do is we want to create the people table, okay. So we are creating people table, and we are copying data from student external to people table, okay. And so let's actually we are going to yeah, so I have to actually execute this guy. People local insert. Yeah, looks like I didn't run it. Okay, so I should say run it. So we should say Hive F, oops. Okay. So now we should have people table with with the just the name and hobby. Okay. Okay. And then I'm going to run the Hive shell, select from people, then I should actually have this result. You can see this is a map reduce job underneath, right? Okay. So now I guess say I go Hive shell and show tables. We should have a people table, and the people table should have data. So you see the people here. So I'm going to say select star from people, and we should see just the name and hobby. Okay, like this. Okay, so I'm going to actually move forward with the presentation because it's already 10 minutes after 4. Let me just see whether there is any. Okay, Hive have a concept of partitions, so let's talk about what it is. So when you're using partition, data in a table is split across multiple partitions, and this is basically to optimize query operations. So in many cases, let me give you a scenario. Suppose you have a weather data. Typically you have a weather data based on year, like a 1990, 1991, 2000, 2001, and things like that. And in many cases, you want to actually perform query operations against that particular year, right? In that case, if you create a data set table per that year, each one will be in fact in the form of a partition. Then when a query is performed on that particular year, as in the form of where clause, then it has to go. It will just go to that the partition for query operation, and it doesn't have to read all the other data, right? So that is the role of the partition. Okay, so mainly to optimize the query operation. So each partition corresponds to particular values of a partition column and stored as a subdirectory within tables directory of HDFS. So as we are going to see in a few minutes, weather data based on year as a partition is a good example. Okay. So when table is queried, where applicable, only the required partition of the tables are queried, thereby reducing I/O required by the query. So this is the example I just talked about. You might want to partition weather data based on year. When the query operation is done per year, only that partition needs to be accessed. Okay, so one or more partition columns may be specified, and create a subdirectory for each value in the column partition column. And yeah, so I'm going to actually explain, and then queries are going to be done using where clause. I'm going to get back to this slide, after I'm showing you examples. Okay. So let's say we have a students, we have a students table, okay, and we want to partition per year. So we have a students who have registered in 1990, and we have a students registered in 1991. So we want to partition. We want to actually partition the data based on year the students have registered. Okay. So we create a table partition by using year. Okay. If you actually show partitions students, we don't see any because we have not loaded any data yet. Okay. By the way, the partition is in the form of subdirectory of the Hive table directory. Remember, Hive table is in the form of a directory under user/hive/warehouse, right? Partition is the same thing. Partition is again another subdirectory under the Hive table directory. Okay. Okay, so now we are going to load the data. So we have a student's data 1990, and you have a student's data 1991. So we want to load this student data 1990 into the students table partitioned by partition year 1990. Okay, so basically it will create another subdirectory called, in fact, partition equal 1990. This is, in fact, the name of the directory we are going to see. Underneath, it will create a directory with this name, and then data will be on that direct sub partition directory. And here we are loading 1991 student data into a partition directory with the name of this. So now when you say show partition students, we should see two partitions. And then you are going to be able to perform query operation based on this partition in a form of where clause. So here, I like to retrieve all students whose birth year is 1990. So yeah, so in this case, the year is actually birth year, not registration year. So this where clause. So when you say start, select start from students where partition year is 1990, it will actually take a look at only the partition directory of this guy. It doesn't have to take a look at all the other years. So, it's going to be a lot more efficient. Okay. This one, retrieve all students whose birth year is 1991. Count the number of students whose birthday is 1990. So, you're basically using this partition year as where clause. Okay. All right. So let's take a look at the lab 3. So this is exactly the same thing. So, we are going to it's basically student HDFS internal partition create. Okay, so we, this guy. Okay, so we are going to run it. Hive. So I'm going to actually have another terminal window. So can I have Hive shell so I have a Hive shell. So we are going to display partitions on the students. So we should have none. Okay, so let's say show partitions student. Okay, so there should be none. Okay, now we are going to load data. Okay, so now load data. So basically we are going to load the partition data. So again here, this is the script. Okay, so this is what I showed you in the slide, right? So I'm going to actually run it. So here, Hive, and we are loading into partitions. Okay, it's again creating. Okay, so now we can say show partitions. Now we should see these two partitions. Okay, now if you take a look at the the actual warehouse directory. So let me show you. I'm gonna go to name node and browse file system, and we are going to go user and Hive and warehouse. Now you see this students, right? Under students, we have these two subdirectories. Okay, so this is a directory. Each of these directories is representing partitioned data. So if I click this guy, I see only 1990 text file. Okay, and again, if I go to this partition directory, it will contain only 1991 text file. So when you are performing query operation only on 1991, it will actually take a look at only this file rather than all the other files. Okay, so that's basically idea. So here we can actually perform. Yeah, so I showed you here. Now we can actually perform query operation. So let's just perform query operation here. And it's going to take a look at only the partition directory of 1990, and it will return the result. Mm-mm. Yes, we can perform various select statement. Now, when you drop this, drop table, and you don't see any students directory, and there are no partitions underneath as well, right? Okay. Here you go. Okay. So here, this is all 1990 as you see. Okay. All right. Okay. Let me just finish up the presentation. Hive also allows joins. Okay, so you can do again inner join and outer join and the right outer join and full outer join. So this is working. This works pretty much like in pig. Okay, so that's exercise 4. And let me finish up with the Hive buckets. Buckets are mechanism to query and examine random samples of data. So breaks data into a set of buckets based on hash function of a bucket column and allows execution of queries on a subset of random data. Okay. Now, it has to be configured. So bucket could be useful when you perform, some kind of operation with the sample data. If you have a huge large data set, and if you do not want to actually use all that large data set, you can actually use a bucket for sampling. Okay. So that's what the bucket is all about. Okay. All right. So I think exercise 4 is basically performing join operation. So again, this is very similar to pick join. So I think I'm gonna just pass or move forward. Okay. All right. So that is the end of Hive presentation. So